Bismillahirrahmanirrahim. Welcome students. Today we will do article 2.3 scalars and vectors. Please open page 33 of your physics book. In physics, we come across various quantities such as mass, length, time, temperature, volume, speed, force, etc. and we divide them into scalars and vectors. So in today's lecture, we will learn the difference between scalar and vector quantities. We will learn how to represent a vector, followed by a small home assignment. So a physical quantity which can be completely described by its magnitude is called a scalar. By physical quantity, I mean a measurable quantity, and by magnitude, I mean a quantity which can be expressed with a number and a unit. So there's a sentence written in front of you. Ruheba walks 2 meters. From the sentence, you're getting a sense that Ruheba has has covered a distance of 2 meters or is covering a distance of 2 meters. So physical quantity is distance, magnitude 2 meters. 2 being a number, meter its unit. The sentence doesn't tell us anything about direction. So we are putting a cross in that column. And we are going to represent this sentence as S. We are using capital S for distance. It is a symbol for distance. Some books use small d as well. There are different notations used, but you have to be specific in using the notations. You can't just conveniently write small s for it because small s is used for second. So you have to be very specific in using symbols. You can't conveniently use small t for temperature and capital T for time. These are specific symbols for physical quantities. So for distance, it is capital S is equal to 2 meters. So scalar quantities are those quantities which are completely described by their magnitude only. Can we add scalars? Let's see 2 examples. I hope Ruheba and Muniba, they don't mind. I'm using their names in the lecture today. So I sense that they're smiling right now. Then I'm also using their names because they did pretty well in tests yesterday. So Zainab adds 5 liters of water in a container which already had 8 liters of water in it. I don't know why Zainab is being so naughty today. She's feeling very naughty. So 8 liters of water is already in the container and she added 5 more. Total volume of water, volume is a quantity mentioned in this example. It is a physical quantity. And when you add the volume of water, 8 plus 5 is equal to 13 liters. 13 liters, 13 being a number, liter is its unit, and V is the volume. So volume is a scalar quantity and it is completely being described by its magnitude. Muniba bought 2 kilogram apples. She bought 2 kilogram more for her friend. Muniba is very generous. Indeed, she is. Yeah, Muniba, I know you are. So the total mass of apples that she bought was M is equal to 4 kg. So if you can see in both the questions, you very easily added the masses and the volumes together. So it means you can easily apply arithmetic operations on scalars. What have we learned up till now about scalars is that these are the quantities that can be expressed completely by magnitude, and they are represented by simple small or capital letters. Arithmetic operations can be easily performed on them, like subtraction, addition, and examples include length, mass, time, temperature, etc. Let's learn about vectors. So physical quantities that can be completely described by magnitude along with its direction. Such quantities are called as vector quantities or simply vectors. Let's see an example. Malaika uses 2 Newton force to push a box eastward. So the physical quantity used over here is force. Since force is a vector, we know now it should be expressed with a magnitude and direction. Let's search for the magnitude in the sentence. So you can see a number and a unit written together. 4 Newton, that is the magnitude. Eastward, it's direction. So vector quantities are those quantities which are described by their magnitude and direction. How can you represent a vector? In the previous example, we were discussing about force. So capital F, we will use capital F. We will not use small f because small f is for frequency. We have to be very particular about the symbols, as I've already said. So capital F with the arrowhead on it, or a bold letter F. Third option is you can use a capital letter F with the arrowhead, or you can use capital F with a cap. This is how you can write a vector, or you can draw the vector as well by using an arrow. It's not any arrow that you can draw with any length. You have to, the tail of the arrow actually represents the magnitude, and the head represents the direction. For example, in the previous case, 4 Newton and eastward. So you have to take 4 Newton as equivalent to some value in centimeters. Let's say 4 Newton is 4 centimeter. So you will take the magnitude, you will draw the tail of a vector 4 centimeter using a scale, and then you will point the arrowhead in the direction of east. As in the previous example, it said eastward. We're going to draw this arrowhead in eastward direction. Can we add or subtract vectors? Yes, we can add or subtract vectors graphically only. Simple arithmetic operations are not possible as direction is involved. You can see a lady over here. She is driving a car. Two forces are acting on it, 50 Newton and 30 Newton in the first picture. Yeah. So both the directions are same. So the total force acting on the car would be 50 Newton plus 30, that is 80 Newton in the direction of west. In the second picture, the two forces acting, but they are in opposite direction. One is 50 Newton, the other is 30 Newton. Since the direction is opposite, you're going to use a negative sign. 50 Newton minus 30 Newton is equal to 20 Newton. And since 50, we're subtracting it, 50 Newton was more, so it is directed towards the west. What have we learned up till now about vectors? The quantities that can be expressed by magnitude and direction. They are represented by bold letter, bar, cap, arrow on the top. Graphically can be expressed too with an arrow. You know, the tail of the arrow represents the length, magnitude, and the arrowhead represents the direction. Arithmetic operations cannot be easily performed on them. Yeah, because direction is involved. Head to tail rule is applied for vector addition. Yeah, head to tail rule concept we will definitely be learning in chapter number 5, and then we will be discussing in detail in that lecture. Examples include velocity, acceleration, force, weight, etc. You can add more to the example. Checkpoint. Let's see, there are some quantities given and see if you can guess them correctly. They're scalars or vectors. 5 meter, it is giving us a sense of distance of some length of some distance, 5 meters. So 5 is the unit, meter is sorry, 5 is unit, 5 is the value, meter is unit. It's a scalar quantity. 30 meter per second east, the direction is involved over here, so it's a vector. 5 miles north, yes, again, it is a vector. 20 degrees Celsius, this is 20 number, Celsius unit of temperature. It's a scalar quantity. 256 bytes. Bytes, you have heard of this unit in digital information and computer information, in computer science. 256 is the number. Bytes, 1 byte is equal to 8 bits. Might have, if you're a computer student, you might be knowing about it. So bytes is a unit. It's a scalar quantity. 4,000 calorie, 4,000 number, calorie unit of heat energy. So it's a scalar. How to represent a vector graphically. 3 simple rules to follow if you want to represent a vector graphically. Firstly, you draw the directions and then select a suitable scale. Directions are important to draw because sometimes they can get really confusing. I also get confused. Where is north? Where is south? Where is west? Where is east? So it's very easy if you draw them, and then it will be easy for you to draw a vector in that plane. Then you select a suitable scale. It's up to you. It's your choice because your scale does not show to show the readings in Newton. So you have to select a scale. For example, over here, 1 centimeter is equal to 10 Newton. It's a convenient scale. Right, to draw 2 lines perpendicular to each other, then draw a line according to the set scale in direction given. That line will be the vector that you are drawing according to the set scale. An example is given below. Represent force of 80 Newton towards east. Firstly, you will draw the directions north, south, east, west so that you know in which direction you have to draw that vector. You will select a suitable scale. I'm selecting over here 1 centimeter is equal to 10 Newton. That is 8 centimeter will be equal to 80 Newton. So basically, if you will draw a line of 8 centimeter, that 8 centimeter line will represent 80 Newton force. You will take 2 perpendicular lines and then you will select the x-axis and y-axis. Of course, you're not going to write x and y, you're going to write north and east because the direction given over here is east. You have to draw the vector in that direction. So when drawing a vector, you have to have a starting point from where to start drawing a vector. That point is O, origin, a reference point. A reference point is a point from which the change in position is observed. So you're going to draw a vector from point O, 8 centimeter in the direction of east. Let's see a second example. Represent force of 80 Newton towards northeast. Again, you will draw the directions. Then you will select a suitable scale. You will draw 2 perpendicular lines. You're just going to magnify this area in short, this northeast area, like this, starting from reference point, that is the origin. You will draw an 8 centimeter line. Since it says northeast, you're going to draw this line in the center. And this 8 centimeter length, you are going to draw this 8 centimeter length using a scale. And that 8 centimeter will be representing 80 Newton force. Summary of today's lecture. Difference between scalar quantities and vector quantities. They're represented by magnitude. Vector quantities represented by magnitude and direction. Scalar quantities can be added or subtracted according to the algebraic rules, and vector quantities cannot be added or subtracted algebraically because direction is involved. And these scalar quantities are represented by ordinary letters, small or capital. However, vector quantities are represented by cap upon letters, bold, arrow, bar, in many ways in which you can represent a vector. Your home assignment for today, you have to represent force of 60 Newton towards northwest, and B part, you have to represent force of 20 Newton towards south. You will follow the steps, those simple steps. First, you will draw the directions, then you will select a suitable scale. You will take 2 perpendicular lines, point O, origin. From there, you will draw the vectors. You have to select a good scale, or you can choose scale 1 centimeter is equal to 10 Newton and then 6 centimeter is equal to 6 Newton. Similarly for 20 Newton as well. It will be pretty easy for you to draw. Second question is write differences between scalars and vectors. Give 3 examples in each case. That will be easy for you if you have understood the lecture, then you will be able to write the differences. So if you still have any queries, you can contact me on my WhatsApp number, share in group. Okay, girls. I hope you got the lecture today. See you tomorrow in the next lecture. Take care. Allah Hafiz.